Pause about another minute and allow those that are just joining in to fully. My name is Robert Wallace. I'm the Regional Marketing Manager and Channel Partner Manager for the Americas for Alpha. And on behalf of Alpha and Hisco, I will be your host today. Today's subject is Alpha Lumet products for the manufacture of LED devices. Our presenter today is Amit Patel, and he is standing by. I just wanted to give everybody a brief background. I think most of you know this is a week-long series of seminars that we put on, or webinars. Hisco and Alpha have had a very long and beneficial association. Hisco has been in business for over 40 years, and for most of that time, they have been a distributor and supplier of Alpha materials. They do a fabulous job for us in stocking in their local stocking facilities, and supplying our mutual customers with Alpha products exactly when our customers need it, and also providing technical support and commercial support to our customers. Hisco came to us a couple months ago with an idea to engage with them in providing a webinar series on solder topics or related solder topics, one per day for a week at a time. And this is actually the second week and actually the last day of this webinar series. We thought it was a great idea, certainly a great way to add value to our customers and to engage with some information sharing with our customers, and so we were delighted to participate. A little, if I could just go over some ground rules. You probably have been muted on the webinar, but if you can, please either mute your computer or your phone if you're calling in so we can limit the amount of background noise. The presentation will take approximately 45 minutes. There'll be a question and answer session at the end. We will basically make sure you're unmuted, and if you'd like to pose a question at that time, you can, or maybe a better option for you to type in the questions that you may have in the chat box. And so Dave, our host from Hisco, will read those off when we get to the question and answer portion. I would like to let you know that be looking in your inbox, in your email inbox in the next few days, and look, there should be an email coming from Hisco, and on that email will be my contact information, my email address, as well as Amit, our presenter today, his email address. If there's any questions or any comments that you have after the fact and you think of it later, please reach out to us and pose that question, and we'll respond to you as quickly as possible. On that email, you'll find a link as well to some white papers of related technical topics that may be of value to you. We're sending that out as a thank you for attending today. And so without further ado, I'm going to turn this over to Amit Patel. And Amit, because I don't have my computer in front of me, I've got some internet issues, I'd like to ask you to please introduce yourself, and please take it away, Amit.
Great. Thank you, Robert. So my name is Amit Patel, and I work with Alpha Assembly Solutions. And my current responsibility is really driving the applications development for the LED-related industry as far as assembly goes. And today, as kind of Robert, to reiterate what Robert said, is that I'm going to be talking about the Alpha Assembly product portfolio that's really dedicated for LED. And really to kind of give you a what's in it for you from this webinar is to really understand the Alpha Energy Technologies overview, what's really the motivation of pursuing the LED industry, what's Alpha's capability today. I'll also go into some LED basics, some of the key markets, what's the future of LED, and then we'll really get down to the important stuff here is really how are some of these LED products assembled, what are the drivers for improvement in LED assembly, and where does Alpha kind of fit in that market. And then I'll cover lastly the dedicated product portfolio that Alpha has to offer for the LED sector. And at the end of the day, my goal is to really make sure that you guys are confident enough to know some basic market and product segmentation for LED offered by Alpha Assembly. So why has Alpha invested into LED? Well, if you really look at the opportunity for consumption of solder material at this level for lighting has not been seen, right? If you take a look at a traditional lighting source like incandescent or CFL, and you give it a tear down, you'll see that there's minimal levels of electronics. But today, an LED light bulb has a lot more integration and complexity inside it. You can see that there's levels of drivers and controls, and also that the light sources themselves, which are the LEDs, need to be assembled. And of course, the growth potential and size, right? There's billions of sockets that are being converted to LED today. And LEDs aren't just used for lighting. I mean, they're used throughout all different types of markets. I'm sure anywhere you go, you'll see them, from automotive headlamps to daytime running lights, roadway lighting, and all the way down to illumination. And what we realized is that the LED component and the LED industry itself has very unique needs and implications when it comes to assembly. One thing that needs to be realized is that LEDs are optical components, right? In the case where the performance can be seen visually. This really drives the development and segmentation of products, and we have a whole brand of assembly materials dedicated to address certain types of unique needs, and this is called the Lumet brand. So Alpha's capabilities today is quite extensive for LED. We have a dedicated LED lab here in Alpha, South Plainfield, New Jersey, and what really that lab is capable of doing is everything from assembling LED packages to doing testing and characterization for reliability. We can measure things like thermal, light output. We can even do a bunch of modeling work as well. And this is just some key contacts. I'll leave this up for a few seconds, but as Robert said, I can be your key contact, and of course, so can Robert if you have any sort of questions or want to follow up. So let's go into some LED basics. So what is an LED? At the end of the day, an LED is a semiconductor, and it's a semiconductor that emits light. It has a positive and negative junction, and as soon as you put current through this chip, it emits two things, heat and light, and I'll get a little bit more into that. Interestingly enough, LEDs can not only emit light we can see, but they can emit light in the ultraviolet spectrum and also the infrared. For example, you can see infrared LEDs used in your remote controls. They're used in all different types of sensors. And ultraviolet is a whole market space that's just emerging. We're still in the infancy stage, but you'll see some really interesting applications come from this in the near future. How an LED chip works. The chip essentially has two layers fundamentally, an N layer and a P layer. And what ends up happening is that an electron wants to find a hole in the P layer, and as soon as you drive current, the electron will fall into a gap which emits light. And a light can be any color spectrum dependent on how it's doped, and it can also, it does also produce heat. So one thing to kind of build on top of that is most of the heat is conducted through the LED. It's not radiated. So if you were to put your hand very close to an LED light source, you'll feel a certain level of warmth. But a lot of the heat actually goes through the die attached material, through the solder, and then the substrate, and out into the open air. So there's so many different types of LED packages that exist today, and this image just sums up the most common types. Everything from PLCC, which is traditionally a lower power type of LED package, lead frame, which is a very robust package. It was used actually in the early days of automotive signal lighting. Two very common LED packages that you'll see today is a ceramic and a chip scale package. And essentially the biggest differences here is that the ceramic and the chip scale packages are SMD type components. The chip scale package is actually a rapidly upcoming package design, because what you essentially see here is that light can be emitted from all directions. meaning that you can pack much more current and effectively get much more lumens out of this LED package. And lumens is how we, it's the unit of light that the industry uses. Light output, I should say. Here's just another slide that shows you different types of packages today. What you see is that some manufacturers will pack much more chips into a single package. If you look at the chip on board, you can see that a manufacturer can use anywhere from 10 to 100 single dies in a package, and a lot of these types of designs are actually used in street lighting. So there are three really current markets that LED is being penetrated into, which is general lighting, automotive, and displays. So general lighting is probably the largest market. It has the widest range of applications, from architectural to entertainment to indoor lighting to roadway lighting. Automotive, I'm sure a lot of you have seen many cars today have LED-based daytime running lights. You can see that the brake lights have been used for quite some time now, but LEDs are also being used for interior applications as well. So this slide just gives you a whole host of applications where LEDs have started to be used. This is an example of a LED tail light. And you can see here that there are these lead frame LEDs that have been assembled on a flexible circuit, and most commonly this is a polyamide type circuit, and it is mounted, in this case, via rivets, but they can be actually mounted via clips and also an adhesive onto a bracket like this. And then, of course, you can see that displays is a very commonly used application for LEDs. Actually, LEDs probably make up 99% of the entire penetration for displays alone. And this just shows you an image of I believe this would be the iPhone 4th generation using LEDs as a backlight. So what about, aside from these three markets, where is LED going? Some applications that are beyond lighting. So you'll see that a lot of designers today are using LEDs in more ways than illumination. And one of these examples is visible light communication. There's actually a commercial product today where you can use the light source to actually send data. And you actually see Acuity has a first commercialized product for this. An example I can also give is a very large supermarket chain in France called Carrefour uses light fixtures from Philips that modulate so fast that you can't necessarily see with your eye, but it can send and receive data to your phone. And this really helps the supermarket or somebody who's utilizing this technology to track traffic patterns and other sort of metrics. LED lighting is also being used in horticulture. In this case, there is a vertical farm in Japan, a completely indoor enclosed system that produces 10,000 lettuce heads in a single day just from using LED light sources. And what they've realized is that LEDs are semiconductors, which means that you can tune them. And what they're figuring out is that some plants, they can optimize the type of light that they give them, which enables the plant to grow much larger and much faster. And this is without the use of pesticides. One of the biggest benefits of using LED light sources is also you can control the amount of water that is consumed by a species of plant. And then I had lightly touched the application of UV. So UV LEDs are being used for things such as disinfection, for curing, and also purification. And then some applications today, as you see with the iWatch, and I think there's a Samsung Galaxy Watch that uses LED sensors. And this is all considered under the wearable space. So a lot of these markets are still sort of up and coming, but you'll see more and more as the years progress, LEDs are an enabling technology for these sectors. So why did I talk about all these different types of applications and markets? Because at the end of the day, they need to be assembled, right? They just don't pop out of thin air. And it just so happens that there's 5 to 6 fundamental manufacturing levels in the LED market, ranging from the ultraviolet to automotive, general lighting, displays, and infrared. And we actually position our core philosophy and product portfolio in each of these sectors because each sector seems to have a unique implication and a need. So Alpha's core really product philosophy is to make sure that we have reliable products that improve lifetime, improve things such as efficiency and brightness, which ultimately will drive the cost per lumen over life. And this is really a metric that the lighting industry uses. How many lumens can I get over my lifetime? Because lumens can translate into dollars. And now we'll briefly touch on the 5 assembly levels in the LED market today. So this image just really sums up all of the 5 levels here, where level 1 is considered to be the die attach stage. It's the stage where the package is actually made. Level 2 is to take this package and assemble it on a board. A very common process we all know of is SMT, right? And then level 4 and 5 is the driver and controls, where you can use things such as dimming, you can integrate things such as Wi-Fi, all different types of control systems and driver systems are used to essentially keep the LED module functional. Taking the level 1, 2, and 4, and 5, you integrate it into level 3, which creates the Luminaire module. And this image just summarizes level 1 to 5 in a single unified image here. So for this talk today, I'll focus on the product portfolio for level 2, level 3, and level 4 and 5. And I just want to say that, you know, the products mentioned today, they address various types of LED industry issues, but you always want to remember in some cases they may not always be the best or most ideal solution. It's always best practice to understand the right fit product for that specific customer. But what I'll present today is a recommended and a clear starting point for that fit for a given assembly level. So we'll start off with level 2 here. Level 2, as I said, is the stage of taking the LED package and mounting it onto a PCB. And this is typically done with a SMT process. There's many types of PCBs that are utilized throughout the industry, and they interestingly fall under different end applications. Moving from left to right from direct-on heatsink typically require the most thermally challenging applications. You'll see some applications used for outdoor lighting have a package directly mounted on a heatsink. Metal core boards are very commonly used for applications that require high lumen output. And then, of course, you have your traditional FR boards, and you also have flexible substrates, and they can really break down into polyamide and PET. So this just shows you a difference of form factors across the level 2 market. You can see that they're all different shapes and designs, from flex to FR to metal core boards. Some of them actually have full array of LED, while others actually incorporate things like ICs and converters and capacitors. In this case, this was pretty a outlandish design where we saw that almost 1,400 LED packages are used in this Luminaire here. From what I understand, this was used for a floodlight type application. So this is a very, very high brightness, a very thermally challenging type of Luminaire here. So one of the key product platforms that are used in the level 2 stage is solder paste. And as I said earlier, the core philosophy, or really the core driver for the Lumet brand, is to look at the reliability, the performance, and how that impacts system cost. So the solder paste role in terms of reliability is to provide a high adhesion and fatigue-resistant interconnects. As far as performance goes, you want a material that has a high level of thermal conductivity, which in some cases require low voiding and also have a low volatile flux residue. As I said, LEDs are optical components, and in some cases you can see that different types of flux residues may outgas and can contaminate the LED. And I'll get a little bit more into that later on. And a lot of this can end up driving the system cost, right? You also want a solder paste that has high stability, a high throughput. For example, transfer efficiency is a good metric used here. So the solder paste positioning really falls into three different segments, from high reliability, which is known as the Maxrel alloy, standard, which is your SAC 305 and low silver alloys, and then of course low temperature, which we are promoting tin bismuth based alloys. So reliability is a pretty key concern, especially for certain types of applications. Different alloys will perform differently under a given thermal cycling condition. And this image just represents a stack of an LED package on a board. And in this case specifically, this is a ceramic LED package on a metal core board. And the reason I use the example of a ceramic package on a metal core board is this is a very commonly used system for outdoor lighting. The reason being is that the metal core board serves as a heat management tool, and the ceramic LED packages are very commonly used because of their high lumen output. The CTE mismatch is very high, the difference at least between the LED ceramic package and the metal core board. And when heat is introduced into this system, the component and board will behave differently in terms of expansion. And the intermediate layer between the package and the board is the solder, and a lot of the stress is absorbed by the solder. If you multiply one cycle, let's say by 1,000 or so, you'll end up getting solder joint degradation over X amount of cycles. So what we're really promoting here is the Maxrel alloy, and Maxrel is a high reliability solder paste that's a creep-resistant solder paste for much more thermally challenging and high reliability environments, from automotive to outdoor lighting. Its benefits are really in thermal cycling and its improved vibration resistance. And here's just the data set that we conducted here. And if you guys want to ever read up more on this, I've cited the technical paper. So if you want to kind of take a little bit more of a deeper dive into the data set and kind of the science behind this, you guys are more than welcome to reference that here. So what you see here is we have ceramic LED packages that we built on a metal core board with Maxrel SAC 305 and a low silver alloy here. That was induced from 0 to 1,000 cycles from, I believe this would be -40 to +125. And what you see here is that we calculated shear strength across these cycles. And Maxrel retained its highest level of shear strength after 1,000 cycles. I will say, though, of course, at the end of the day, Maxrel isn't the go-to alloy for all applications. SAC 305 is viable for certain types of applications that don't require that level of high reliability. But in the case of applications like automotive and streetlights, for example, where the CTE mismatch can be high, Maxrel can improve the lifetime performance for this application. Here's another independent study that we conducted. Again, this is -40 to +125 from 0 to 1,000 cycles. But in this case, instead of measuring the shear value, we measured light output. And after 1,000 cycles, you can see that Maxrel still retained 80% of the LEDs on, whereas SAC 305 had just under 20% of the LEDs still on after 1,000 cycles. Low temperature alloys are actually very commonly used for applications where heat sensitive components are used. And in some cases, you'll see that LED boards have a white solder mask, and the reason is because they require or have a need to maintain a certain level of brightness. So instead of using a conventional green solder mask, a white solder mask is used, and in some cases, this can be susceptible to browning. A low temperature solder that's less than 180 C can help reduce the level of browning we've seen with some of our customers. In other cases, you'll see that a low temperature alloy is used to eliminate wave soldering or to reduce energy consumption of a certain type of process. So what we're really introducing here is a low temperature alloy we call SPX02, which is actually our new generation tin bismuth higher reliability alloy. And it really has the benefits over its traditional tin bismuth alloy to provide improved drop shock performance, and it seems to get a better thermal cycling property. This slide, I won't really cover each row by row, but it gives you the alloy property differentiation between two low temperature alloys, which is our traditional tin bismuth silver versus SPX02. And what you want to really take a look at is the second to last row, which is the creep rupture time. SPX02 performs closer to a SAC305 alloy than it does with a tin, as opposed to a tin bismuth. Here's another data set that shows you the effect of thermal cycling on shear strength between SPX02 and a tin bismuth silver alloy. And this is shear force as a function of -40 to plus 125 125 C across 1,000 cycles. And we're offering this SPX02 alloy in Lumet P53. And Lumet P53 is our next generation low temperature solder paste. And what this really enables is LEDs to be assembled on PET circuits. And the reason is that the two biggest types of flexible circuits used today can be polyamide and PET. Of course, polyamide is a much more robust type of flexible circuit, but it is much more expensive than PET. PET, however, can't withstand a traditional 240 peak reflow. So you need to use a low temperature assembly to run this process. And what we did here was we assembled mid-power LED packages on a PET flex circuit. And what we ended up doing is we subjected it to -40 to plus 85 C thermal cycle all the way to 2,000 cycles. And we see here that we get no current degradation across 2,000 cycles using SPX02 on a PET circuit. Moving on to performance. As I said, LEDs, when you turn them on, they produce two things. They produce heat and they produce light. Just to give you some perspective, an LED package typically produces a ratio of 60% heat, 40% light. An incandescent bulb will produce somewhere around 90% heat and 10% light. So you can just clearly see the amount of efficiency an LED has over an incandescent lamp. But heat is a critical stress on the LED in the case that it impacts the lifetime. And what you see here on the bottom right corner is a graph that comes from Philips, which shows the lifetime given the junction temperature of the LED. So if you look at that purple line here, you can see that if you drive an LED at 1.5 amps, which produces a junction temperature of 130 C, and you're able to reduce it just by 10 degrees to 120 with a, let's say, high thermally conductive material, you can effectively increase the lifetime by a factor of 2. Some of the things that really impact thermal efficiency or thermal transfer is voiding. Voiding, of course, are just large pockets of air, and in this case, solder paste can produce different types of void levels, right? Different chemistries coupled with different design and processes will reveal different types of voiding. And this image just shows you that there's the two different pastes used on the same exact component, on the same exact board, under the same exact process conditions can reveal two different types of void percentages. For here, we've introduced, this is actually a newly introduced product called Lumet P30 in SAC 305, which is a solder paste that we're offering as our current lowest voiding level solder paste. And this is a study that we conducted in terms of showing a optimization study for voiding across different stencil designs. And what you'll see here is from left to right is different stencil designs showing the volume of solder. So on the left-handmost side, you see a 5 mil thick stencil. All the way down to the right-handmost side is a 3 mil thick stencil. And across the entire board, we're able to achieve under 5% voiding for a mid-power LED package on a ceramic board here. Here's just another example of voiding on a MLF 100 component. So really kind of summarizing a Lumet P30, we're able to achieve a IPC Class 3 rating on SAC 305 and under the Maxrel alloy as well here. And now moving on to level 3. So level 3, as I said, is the integration stage. It's the stage where the LED lamp is actually created. It's taking the level 2 and the level 4 and 5 to create the lamp. The level 3 stage is typically done to connect things such as the LED engine to the power drive and control, and this is done very typically with solder wire. And what you see here are just 3 different types of applications that use solder wire to make this connection. Interestingly enough, you can see that solder wire is also used to do the end cap assembly. And this is pretty interesting because there's a large volume of solder that's used here, and we get some pretty interesting requirements from some of our customers regarding the assembly at this stage. If you really look at traditionally solder assemblies, they're all internal, meaning that at the consumer level, you don't see the solder physically. But in the case of an LED lamp here, you can see that the solder is actually exposed. And some of our customers actually ask for a very aesthetically pleasing solder joint. What we're really promoting here is the Alpha HF850 solder, cord wire solder, which really promotes ultra-low spattering. It's fast wetting, halogen-free, and it produces some of the most reflective solder cosmetics. And this slide just shows you some of the tests that the HF850 tin copper solder wire passes. And by the way, I will mention that these slides will be available to you to kind of look at it further. So moving on, you can see that here we are measuring things such as solder aesthetics, spreadability, and spatter for the HF850. We conducted a benchmark study between the HF850 tin copper versus a competitor product, and here's a side-by-side comparison of the level of shininess that the solder joint produces. As I said, aesthetics seems to be a voice of customer metric, especially for end cap assemblies. You can see that the top row produces a much more clear-coated shiny joint versus the bottom row produces almost a speckled, duller surface. We actually went one step further and quantified the reflection percentages of these solders. And what you see in green, which is the competitor, and the blue, which is alpha, is that across varying tip temperatures, alpha still retains its relative reflection percentage. In the case of the competitor, as you see, it decreases with a higher tip temperature. And the reason is because at the higher tip temperatures, the flux started to burn. We also conducted a solder spreadability test. We ran a GIS spread test from 0.2 grams to 0.5 grams to produce the control chart below. And to give you an example, we measured the amount of mass needed to produce a diameter of X. And in this case, I'll use the example of 10 millimeters. And the reason I'll use 10 millimeters is because that's the typical diameter of an end cap. That's where the solder is actually used on. In the case of the alpha HF850 tin copper, you can see that we need roughly 0.2 grams worth of solder to produce a diameter of 10 millimeters. In the case of the competitor, we need almost 0.3 grams to produce the same diameter space or coverage of 10 millimeters. Moving on to the flux spatter test, flux spatter can be a hindrance to an LED assembly because, as I said before, LEDs are optical components. Flux spatter landing on the silicon lens can contaminate the lens, impacting light output over time. In this case, we ran the IPC test method 2.4.48, which shows us that Alpha's HF850 tin copper produces 4 times less flux spatter than the competitor wire here. Moving on to level 4 and 5. Level 4 and 5 is essentially the driver and control assembly, and this is what we consider almost a traditional type of assembly, where it's a mixed assembly between SMT and wave. Here are just some examples to show you different types of power driver and controls assemblies used today. Typically, power drivers and controls are used and integrated into the LED lamp itself, or they can be standalone modules such as inverters and ballasts. For this, we're promoting the Alpha SNCX Plus 07 solder bar. And here's just some alloy properties showing the differences between the SNCX alloy versus a SN100C, SACX Plus 0307, tin copper, and SAC 305. Really moving on to the mechanical properties here, this just gives you an idea as to what the differences are between a as cast and then the alloy after aging for 125 hours, 125C for 96 hours. In terms of wetting performance, we can see that the wetting speed performance, the best was produced by SAC 305, but second comes SNCX Plus 07. SNCX Plus 07 is really ideal for improving the dross rate or reducing it in this case. And you can see here to show you this graph just shows you the dross in grams over X amount of hours here. And again, just taking a look at the alloy surface appearance, it seems it is an important metric in the LED sector, especially for things such as end caps. You can see that the surface alloy has an impact in some cases. And just to really summarize the product portfolio, this is pretty much all the products that I spoke about today, and really we're promoting everything from solder paste to cord wire to solder bar. And this, in my opinion, has to be probably one of the most useful takeaway slides here, because what it really shows is a recommendation or a product positioning for a given application. And what you see here is essentially our Lumet brand of solder pastes, from the high reliability Maxrel to the SAC 305 to the SACX Plus 0807, which are low silvers, all the way to the tin bismuth. And what you see here is on your x-axis is operating power driven by your y-axis of thermal cycles. So for your high power and ultra high power assemblies, which are typically done on a metal core board, where the CTE mismatch is high, most commonly a high reliability alloy is needed. And this is why you'll see that the Maxrel alloy covers this space. Whereas something like flexible substrates, which utilize low to mid power LEDs, you don't need any thermally challenging sort of application is used. So something such as the tin bismuth alloy can be utilized here. We went one step further, and essentially these are just this is essentially the same exact slide I showed previously, except the blue arrows just indicate typical applications as a function of junction temperature. To give an example again, street lamps produce some of the highest lumen outputs. So typically you can see a street lamp produce anywhere from 10,000 lumens to 25,000 plus lumens. To give you some perspective, your lamp that you use in your home that produces only 800 lumens. So you can see that these are very high lumen output lamps, and they essentially need to be used on metal core boards here. We've also done the same exact chart, except in this case, this is for displays and projection, where your most thermally challenging applications are your projectors and your entertainment lights, and the very low power applications can be things such as backlighting for mobile handsets. And very commonly used, backlights will use either an FR or a flexible circuit type material, typically polyamide. And then lastly, we did it for automotive lighting as well, where you can see that headlamps are, again, your most thermally challenging applications, and whereas applications such as interior lighting very commonly use low power LEDs, again, which are less than half a watt. And this slide just shows you essentially that Alpha plays a product positioning in every single assembly stage from level 1, which is our die attach, to level 2, to level 3, and level 4 and 5. And this essentially concludes my talk for today, and I really want to thank everyone who stayed for the webinar. And I hope you guys learned just a little bit more about Alpha's positioning for the LED sector. And again, a huge thanks to Hisco for setting up this entire week's webinar.
Very good, Amit. Great stuff, and we really appreciate your presentation. Dave, I was going to ask, was there any questions that have been typed in? Are you going to open it up for questions from the floor? What do we have there?
Yes, if anybody has a question now, please use the chat box to type it in. Let's give people a few minutes to submit some questions. We don't have any at the moment.
Okay. Well, while we're waiting, I just want to remind everybody, again, this is Robert Wallace with Alpha, that please be looking for an email in the next few days from Hisco. And again, it has my email and contact information on it, as well as Amit's. If there's any questions that come to mind after the conclusion of the webinar today that you didn't get to ask during the webinar, then certainly type those off and send that email off to either Amit or I, and we'll get those questions answered for you. On that same email will be a link to an ebook basically with white papers on related subjects that you might find interesting. And we always encourage you to visit either the Hisco or the Alpha website for further information. And as a matter of fact, a lot of the same information that Amit shared with you with regard to the products, we have the individual products listed on our website, and you can also get tech bulletins and pull those off of the Alpha website. So, Dave, have we got any questions posed thus far?
No, I guess, Amit, you were just incredibly succinct and clear in the presentation.
Thank you so much.
Well, very good. Okay. I guess if there's no questions from the floor, we certainly, again, appreciate everybody, your time and participating with us today. We value you as customers, and please go off and have a great weekend, and happy Friday to everybody. And that will conclude today's proceedings. Thank you very much.
Thank you. Have a great weekend.